Hello and welcome to an overview of the NPV and the IRR. These are two financial analysis tools that are often used in assessing the viability of projects. In other words, quantitative project selection methods. The concepts can be a bit abstract, so let's take a look at some preliminaries before we actually work a problem. First of all, I think everyone would understand that if you had $100 in your pocket today, and you would put it in the bank earning 5%. Of course, earning 5% today wouldn't be easy, but let's assume you could. If you could earn 5% over a year's time, how much would your $100 be worth a year from now? It would be 100 times 1.05, which is $105. I think we all get that. This is pretty much common sense. What is a little more abstract is looking at this in reverse. What if you didn't have $100 today, but someone promised $100 a year from now? So we can ask the question, how much is $100 promised in 1 year actually effectively worth today? If we once again assume 5% interest, then we could just do the reverse of the previous equation. 100 divided by 1.05 equals 95.24. So that means using a discount rate, in this case the interest rate, it's often referred to the discount rate because you're factoring in reverse. Using a discount rate of 5%, $100 a year from now is worth $95.24 today. That's the present value of $100 given to you in the future. To help think of this in a common sense way, this is like saying if you had $95.24 and you put it in the bank today, at 5% in 1 year, that would equal $100. Okay, so the present value of $100 in the future, assuming 5% and assuming 1 year time, is 95.24. So some terms to remember here. In this case, the interest rate is referred to as the discount rate. You're taking a future value and you're valuing that in today's worth. So this is what we mean when we say present value. How much is future money worth today? And it's calculated by factoring in the interest rate. Okay, what about more than 1 year? Well, we saw in 1 year, if you put your money in the bank at 5%, you get $105. In 2 years, you would take 100 times 1.05, which is $105. You would earn interest not only on that 100, but on the interest that was paid after 1 year. So it's 100 times 1.05 times 1.05, which is equal to 110 in 2 years. In 3 years, it's 100 times 1.05 times 1.05. So if we were going to summarize this in a simple shorthand way, you would have, in 1 year, it's 100 times 1.05. That calculates the effect of 5%. 2 years is 100 times 1.05 raised to the second power, or 1.05 square. A number times itself is squared, or raised to the second power. In 3 years, it's 100 times 1.05 to the third power. So when you're putting money in the bank and you've got more than 1 year or more than one period, it's money times the rate raised to the period in. In this case, we've seen raised to the first power, the second power, and the third power. Okay, so that's how you calculate money in the future that you've invested today. Now what about the reverse? Let's take the reverse example again. Well, you would use the same principle as you did with 1 year. For example, what about $100 promised in 3 years? That would be 100 divided by 1.05 raised to the third power, or 100 divided by 1.16, which is 86.38. Another way of thinking about this is if you had $86.38 and put it in the bank today, earning 5% per year, in 3 years it would be worth $100. In this case, 1.05 is the discount rate. The 3 there refers to the 3 periods, or 3 years in this case. So some observations that you should think about is the longer you have to wait for the promised money, the less it's worth today. The higher the discount rate, the less the money is effectively worth today. For example, if this was 1.1, like 10% instead of 5%, it would be less than 86.38. So this infers in project management terms and analyzing or assessing the viability of projects, the higher the discount or the hurdle rate, as it's sometimes referred to, the more money your project will need to generate in order to compensate for that high interest or high discount or high hurdle rate, as it's sometimes referred to. Now, some complicating factors. What if the future cash flow is risky? For example, what if it's your brother-in-law that's promising $100 in 1 year? Well, to factor in risk, you increase the interest or increase the discount rate. This effectively means, well, if there's uncertainty involved, I better have more cash flow coming in, more reward to cover my risk. And that's reflected by putting in a higher discount rate. Okay, now what about if you're expecting inflation in the future? You just add the inflation to your discount rate. An interest rate of 5% with an expectation of 1% inflation is 6%. The rationale, your future cash flow is worth less than it otherwise would be because inflation, like the money coming in tomorrow, is worth less, so you need to have more of it. And the way you reflect that is increasing the discount rate. So in general, the higher the discount rate used, the more future cash flow will be needed in order to justify the project. In other words, more risk, more reward. So that's it for part one. For part two, we're going to take these principles and actually use them in a project selection problem.